Alright, this is chapter 2 in a nutshell review. It's over percents. To review what a percent is, here's the percent sign. You might notice it's made out of 2 zeros and what is a slanted 1. That reminds you it's division, because of course a division looks like this. Two things on top of each other means division. It also reminds you it's 100. You can see the 1 right there in the middle, and you can see the 2 zeros. So that is what it means. It means divide by 100. Per means divide. Cent means 100. 100 cents in a dollar, 100 years in a century, 100 centimeters in a meter. Centurion was a Roman soldier who was in charge of 100 soldiers. Anyway, cent it means 100, and per, of course, means divide. What we need to know is percents always compare to a whole. So we're always going to, it's basically a common denominator. It's saying we're going to take everything to a common denominator that everybody understands. Like if I have thirds and sevenths, I could go to 21st. But 21st is the number that we don't really understand that well, but everybody understands 100 pretty well because we've dealt with money long enough. So we're going to go to a common denominator of 100, even if it doesn't go evenly into 100. All right. I also like to remind you that it's a selfie of a number. It's been cleaned up and made pretty. Remember how I talk about if you're taking a selfie of yourself, guys, we don't take a whole lot of selfies, but girls take like 600 selfies. And then they put like 13 filters on it. They take it from the best angle, and then out of those 600, they pick the very best one. They clean it up, they filter it, they make it look perfect. And that's kind of what a percent is it's been cleaned up and made pretty so everybody understands it. When you go to do math with it, though, you have to actually go back and do math with the real number. So the percent really just represents a fraction or a decimal. So remember, to change a fraction to a decimal, we divide. Top number goes in the box. To change a decimal to a percent, we move the decimal 2 places to the right, which means you multiplied by 100. And that's why when it is a percent, why can I not write that 0? When it is a percent, we want to bounce that decimal 2 places back to the left, which means divide by 100. And so now we're doing what it says, percent. When it says 70%, it's saying 70 divided by 100, which would change it back to a decimal. And then read it, and it becomes a fraction. Okay, so that's a quick review on how to make it play nicely as a non-selfie version. If you need to be doing math with it, you need to be doing it as a fraction or a decimal. I'm not going to work all these out, but I'm going to set them up for you to remind you. You can do these in 2 different ways. You can write, these are what I consider is-of problems, which if you think about percents, the of is going to be the whole number every time, and the is going to be the part. And so you can do it with an algebraic equation, but remember, that percent is a selfie of a number, so we need to change it to a decimal or a fraction. So I'm going to write that as 0.35. Of means times. 62 is means equals. And what number we don't know, so it's set up to solve. You're going to find that most of my students like the proportion better because it's always is over of, which is part over whole, equals percent over 100. And then it's just a matter of putting them in the right spots. The percent is right there. So it's really like you have a percent side and you have a real number side over here. And so now, of 62, the 62 is the 100%, and we're looking for the part. You'd be ready to multiply the diagonals and divide by the other one. Here that is again. Oh, that's supposed to be a T right there, sorry. 14 is what percent? I don't know. Of 85. Now this one you got to be careful with because when you solve it, it's going to be a real number and you need to clean it up and make it pretty. So if you solve it, you'll then have to move your decimal 2 places. If you do it with a percent, you don't have to because it's already going to be done for you. 14 is what percent of 85? 85 is the 100%. 14 is going to be the full percent. You're ready to multiply and divide. I'll try that again. 75 is, can't do it with 90%. That's a selfie, so I'd move the decimal 2 places. Of what number? Don't know, so I set it up and I have it as an algebraic equation. Or set up as a proportion. 75 is, it's the 90%, and we want to know the 100%. We can ready to multiply and divide. A lot of times we deal with these percents with taxes and tips and discounts and things like that. So here on the first problem, we have a $78 item. I'm going to draw a picture of that. And then it's on sale. It's 30% off. So it's like we're taking 30 pieces out of 100, which would be about that big, and we're chopping that price off. So when you set that proportion up, you could say, well, 78 is the 100%. Now you have 2 different ways to doing it. Either you take and find the 30%, but then you have to take it off, which means you'll then subtract that amount. Or you could do the subtraction before and say, well, 30% off means I really want to know this amount, which is the 70%. So I'm going to take 70% of it. So if you did it with the 70%, you'll be right to your answer. If you do it with the 30%, again, you have to subtract. Next one, you're buying a car that costs $16,500, and they're going to charge you sales tax. They're going to charge you 8.6% sales tax. Not a very big piece, but what they're going to do is they're going to tack that on. So your answer is going to be bigger than $16,500, of course. So again, you can do it in two different ways. The 100% price is $16,500. You could solve it with the 8.6%, and that only solves for the tax, which is this piece. So then you would need to add that on once you get that answer. Or you could say, you know what? I have to buy 100% of the car and 8.6%, so I need 108.6%. That will then pay for this 100% and this 8%. You'd be right to your answer if you use that one. Doesn't matter which way you do it. They're both the same math. Either you add before or you add after. Now the problem is on the last question, it says how much will an $8 item cost after a 10% discount and then a 10% sales tax? Well, a lot of people think, well, if you take off 10% and add 10%, you're going to be right back where you started. But you've got to be careful with that one because you're going to be taking 10% of two different numbers. So let me show you that. So I set that up. It's an $8 item. The first thing that happens is I take off 10%. I'm just going to do this one fully. So if I take off 10%, I'd be ready to multiply and divide, and that would be 80 cents. And now it'd be $7.20 when I subtract it. Or you could say, well, 10% less than is 90% remaining, and you'd still be to an answer of $7.20. Now here's the rub on this one. Now when you take it up there, you're not being charged tax on an $8 item, you're being charged tax on a $7.20 item. So again, you set it up, put in your 10, right? Or you could put in your 110, because this is just the tax. This is the item plus the tax, right? Either way you solve it this time, if you found that 10%, it wouldn't be 80 cents, it would only be 72 cents. And then when you tack that 72 cents on, it's only going to be $7.92. Do you understand why it didn't come back to 8? It's because you took off 10% of $8 and you added on 10% of $7.92. I don't know, or $7.20, excuse me. And so that makes it not get all the way back to that $8 amount. We then went into percent error and percent change. One extra step on these, and that is you need to be comparing, because we're not just finding the percent, we're finding the percent error or the percent change. On this second one, I think it's percent change or percent profit. So I'm going to label that percent profit. That means that this number over here has to be labeled the same. This needs to be my error. If I guessed 17, but he was actually 22, then I need to subtract those and find out my error was 5. And then I always want to compare it to these two down here should be labeled actual or original. If you're doing an error one, we need to compare it to what he actually is. He wasn't actually 17, he was actually 22. Now you'd be ready to multiply and divide. And on the bottom one, let's do the bottom one as well. I bought it for 25 and sold it for 61. Well, that means I made a what? If I subtract those, I get $36. I made a $36 profit, right? And I want to compare that to what I originally paid, which is 25. I made over 100% profit on this. I'm ready to multiply and divide. And the reason we do this percent change and percent error thing is, listen, if I missed by 5, is that a good guess or a bad guess? Well, it's according. If I had a jar of jelly beans that had 14,000 jelly beans in it, and I guessed how many jelly beans there are, and I missed it by 5, that's a pretty amazing guess. I was off by 5 compared to 14,000. But if I had a jar of jelly beans that only had 3 jelly beans in it, and I guessed 8 and missed it by 5, now that guess is really terrible. So you can tell that just knowing 5 off doesn't tell you as much as knowing 5 compared to how many there were, right? It's kind of like the second one. If I make $25, is that a good deal? Well, or excuse me, $36. If I make $36, is that a good deal? Well, if I make $36 on selling a $10 calculator, yeah, it's an amazing deal because it's only worth $10 and I sold it for $46. But if I sell my $1.4 million yacht and only make $36 profit, it's not a very big profit, is it? Last one is simple interest. And remember, interest is the amount extra that you pay to borrow money over time, or to lend money over time. You get paid interest. So the formula is just interest equals principal times rate times time, where principal is the amount of money that you borrow or loan. Rate is what percentage is agreed to pay, and time is always in years. So let me set that first one up. I borrowed $4,000. That would be the principal. At 3.4%, of course, I'm going to have to change it to an actual number, not a selfie. And this time it says 30 months. How do I write 30 months in years? It's 30/12ths of a month. And this time the variable's by itself, so all I have to do is multiply those three, and it will tell me how much interest I'll have to pay on this borrowing of $4,000. Next one, I'm putting money in, and I earned $1,840 of interest. So this time I know the interest. I know my deposit was $20,000. That's the principal. I know my time was 4 years, and it's in years, so I don't have to write it in any weird way. I just don't know the rate. So now we would be doing what? We're not doing this problem, we're undoing this problem. So I would combine my two multiplications here, and they would take 80,000 R equals 1,840. And then I need to remember, when I do this one, I want it as a rate. So after I get my answer, which is going to be a decimal, I need to move the decimal 2 places and put a percent sign behind it to have my answer. That's a little bit of each and everything that we did in this chapter.